Hello people, this is tutorial number 31 that I'm preparing for the playlist, which is called Kinematics Scenario Animation and Simulation Modeling in 3D Experience. So we will be using the portion of the software that's buried in 3D Experience uh, and allows you to perform kinematic and dynamic simulation. The particular problem that I'm looking at is uh, a wheel, two wheels basically, on an axle, which is embedded inside of a frame, as you'll see in a minute. And this wheel is supposed to roll on a path that is defined down here. Okay. Now, uh, when the rolling takes place, this uh, frame is supposed to stay horizontal, obviously. And I did a simplified version of this problem back in tutorial 10. There was no frame, there was a single wheel which was supposed to be rolling along a path. So what I'm doing now is a bit more a complicated version of that. And a couple of comments that I want to make, and that is there are many ways of doing problem like this. Also, the CATIA V5's version of this problem is going to be on YouTube and available on 26th of February. So if you're a CATIA V5 user and you want to see how that is done there, this is the link that you want to check on February 26th. Now, the way we're going to do this later on is we have obviously a revolute between the axle slash wheel axle and the frame, a roll curve joint between the periphery of this outer periphery of this wheel and the path that I'm going to make on the ground. And in order to make sure that this frame stays horizontal, one way of doing it is to create a planar joint between the top of this frame and a plane that we create later on and is at the same height as the top of that plane. Okay, so we will see that in a minute. So here's the situation. We basically have the ground and there is a path on it right there. We have a wheel slash axle. It's just a single part like that. And then we have a frame like so. So when you put these things together and you uh, make the wheel roll on that, the solution to our problem is going to be obtained. Now, a couple of things. Notice that when you do 3D experience, the roll curve and planar does not appear in the common or very frequently used joints, which are here. What you need to do is to click on engineering connection, and then you have the entire menu, and the one that you want planar is over here, and the roll curve joint is over there. Okay. Now, a couple of things. Notice that when you look at this problem, I have I have two planes here, which is not clear why we need them. Of course, if you watch tutorial 10, you would know. But anyway, we have two planes here and also a point there on the periphery. Now, these I have not created, and I will be doing that. I'm not going to create the wheel axle geometry or the frame geometry or the ground because they're simple, but I'll take things from that point on. Okay, so let's go back here. These are the parts that we are using. There is the ground. Here's the ground. This is the ground, and I haven't plotted my curve on it, the path on it. We have the wheel axle right there. You see this, and finally we have the frame right there. Okay. Now, first thing I'm going to do is I go to the ground, which is the first part, and I draw my path because I decided not to do that ahead of time. On that plane, I will sketch. Why don't I use a spline here? Spline, for example, going from there to there to there to there. Okay, so there we are, exit. So that's going to be the path. Now, the other thing is that I need a point. I need two things: a point on this outside of this rim. So this is in the wheel axle, the second part, right there. It's right here. Double click on it. So we are in part design, and we are in that part, the part that describes the wheel and axle. So I'll make a point, and it really doesn't matter where, except on that preference, but I will make it on the curve, and I select any old point will do. Right there, you can see that. I selected this. One more thing, in here, I need a plane halfway between these two sides of the wheel, because later on I'm going to do a revolute joint. So what I'm going to do is I'm going to make a plane, and we are still in the wheel axle, the second piece, second part, and between the method that I'm going to use is between this plane and that plane, okay, at 50% or 0.5, which is exactly in the middle, and we say okay. So there we are. Excellent. Now, the next thing I'm going to do is I'm going to hide these planes, these XYZ planes. I don't need them, so let me go ahead and do the long way. We select with the control, we select we select them. The faster way of doing it, using the find and select, control F, or I'm not going to do it like that. Let me hide all of these. There. Okay, I don't want to hide these two. Okay, next thing I'm going to do is to uh, uh, now remember, what you need to do is you have to bring this wheel down and put it on that path. In order for us to have a roll curve joint, the wheel, the boundary of the wheel, this circle here, must be tangent to that curve. It has to be. Now, because I did not bother doing a lot of extra work at the beginning, what I'm going to do is I'm going to create two planes here. One of them is the normal to the plane. The other one is the 90 degree, the plane at 90 degree to that normal, which is going to make a tangent. And when I bring that face and put it in that second plane, obviously it's going to become tangent to that curve. So here we are. Let's go back to this part. This is the ground. I am in the ground. You can see that right there. Okay. And I'm going to create one plane. And the method of making the plane is through a point, normal to a curve. So let's see if we can find it. Normal to a curve. Select the curve. Select the location where it's going to be normal right there. Okay. Now, what I want to do is I want to draw a plane in that same part, which is 90 degrees to that. So let's do another plane. And the method that we're going to make that plane is the following. We're going to say angle and normal to a plane. This is the method that I'm going to be using. It says, where is the rotation axis? I want the rotation axis to be the line that goes from this point all the way up, and I don't have it. So we can actually go and create it, create a line. Point and direction, there is the point. Direction is Z. And the length here, that's fine. There is a line. And it says, where is the plane that you want to rotate about that line? Well, it's the plane that I created normal, and it's 90 degrees, and there we are. So notice that we now have a plane here, which is tangent to that path, and that explains these two planes that I have here. Okay? All right. We are in good shape, so let's do the following. Why don't we first of all, we fix the ground, fix the first part. So let's go to part assembly design, and we're going to go to fix right there, fix, and fix the first part. So that's going to be, let me see that. Yeah, fix it, and it's fixed now. You can see that the ground is fixed. Good. Now I want to bring this, for example, this wheel and put it on that ground. And the way we're going to do that is I'm going to create a whole bunch of uh, constraints, which I'm going to delete later on. Okay. So let's go and do it, engineering connection. Okay. This one is see, user defined. This one is contact. Okay, see, add contact constraint. So on contact between the face the face of this wheel and the ground, and then we say okay, no, and update. There we are. Okay, good. Now we're going to put this wheel in that tangent plane. So we go another one. Incidentally, if it doesn't look the way you want it, you just have to change the direction of that contact. Okay, well that's okay. What do I mean by change direction of that contact? See, let me show you. Let's go back here. Let me, instead of what I have here, click this. Look, that's not what I want. That's what I want. Okay. So if it doesn't look the way you want it, just go and clean it up. We do another one. I'm gonna delete that contact later on. Later on, I'm gonna delete it. So we do another one, another engineering connection, and it's going to be the coincidence between this plane and that plane. And it's going to be a new one. And then we say okay, and no, and update. Now notice that it is actually in that plane. You can see that this face of that wheel is actually in that plane, but I want to bring that point and put it right there. That's why I created this point. So we go another engineering correction, coincidence between the point that I created there and this point. Okay, and it's a new one, and then we say okay, and no. Okay, so that tells you how I bring this piece and put it right there at the beginning. All right, now this is good. So now I want to assemble this frame into that into this axle. So let's go ahead and do that. We go. By the way, all of these I'm gonna delete. Okay, all of these I'm gonna delete. These things that I created. These three I'm gonna delete. Okay? I can delete it now, but I'll just leave it the way it is. So we do to bring this thing and put it there. One way is to go and make it make a revolute join, a revolute. And the way I'm going to make this revolute is this uh, template here. 1, 2, 3, 4. This template, axis, plane. So I want the axis of this hole to be aligned with the axis of that axle. And I want the center plane of this frame to be aligned with the center plane of that axle. There we are. And then we say, and I don't need this angle constraint, so I'm just going to delete it. And then we can close it. And no. Okay, I've created a bunch of things here, which some of them I want to delete. For example, I want to delete this contact, which allowed me to bring the wheel and put it on the ground. I want to delete that. Or you can deactivate it. I want to delete this planar one. And that spherical one, remember I put the one point coincident with the other point, that turns into a spherical. The revolute I want. Now, the other thing is that notice that I want this frame to remain horizontal. I don't want it to tilt. One way to do that is create a plane this height and then make a planar joint between that plane and the top face of this. There are other ways of doing it. Okay. So here's what I'm going to do. I will go to the ground right there. And in here, I'm in the ground right now. I'm going to make a plane, and the plane I want it to be at the same height as this. And the easiest way to do that is say, okay, you know what? I'm going to make it through 3 points. This plane, I'm going to make it through that point, and this point, and that point. So a plane is created here. This plane is actually at the same height, but it's in the ground. Okay. So now we go to the assembly design and we create a planar joint. Now the planar joint, notice that you don't have it here, but I told you how to fix it. Go to engineering connection, use the pull down menu. Here's the planar and plane to plane, right there, plane and plane. So for example, this plane and that plane, and then we say okay and no. So a planar joint has been created here. All right, and this is pretty much it. So let's go ahead all the way to the top, all the way to the top. Save everything. Hopefully I didn't forget anything. I'm pretty sure it's okay. All right. So now we go to the mechanical, the application mechanical systems design. Okay. First of all, let's create our mechanism representation. Click on that. This is fine. Let's look at the joints that we have. We have a fixed joint for the ground. We have a revolute. We should have a revolute and we should have a planar. Right there. Now, if I had not deleted some of these, they may have appeared in this list as long as there is no contradiction with the other joints. And we don't want them to participate. I could have left these alone, but then over here unchecked them. But I decided not to. Now, there's one thing here. I want to show you something. Let me click on this planar. Notice that, sorry, not the planar, the revolute. Sorry. Yeah. Never mind right now. That's fine. Okay, I'm getting ahead of myself. Now, what do we want? We want a roll curve joint. Now, I could have done this thing before I created the mechanism, but I forgot. So can I do that now? Yes, of course, here. Engineering connection, use the pull down menu, and scroll down until you find the roll curve joint. It's asking for two curves. The periphery of that wheel is one, and this spline that I drew is the other one. Okay. Now, I'll come down to this in a minute. Say okay and no. Now, let's go and check our joints. You click on the mechanism manager. Notice that because I did that just now, it is not part of this set of joints. So check it. Now it's going to be there. But I also want to point out to you that this does not have any command. So two commands associated with it. All I need is one of them. We say, okay, now there is a command. And if I go to the mechanism player, notice that there's a sliding bar here. You can see that. Oh, very good. You see? Okay, let's actually change the size of this thing to let me reset this thing. I want to change this to make it bigger. Okay, so let's see now. To make it bigger, what I can do is the different ways of doing it. You go to the roll curve joint limit. Let me change the upper limit to 500. Close it. Now we go to the mechanism player. See, we can move it all the way to 500. Right there. Right there. All right. So that's it. There's no physics here. It follows what I want, except that there's no physics. In other words, I can specify the velocity, etc. But this is what I promised to do for you in this tutorial, and it's done. All right.